All right, we're in section 1.1 where we are going to identify points, lines, and planes. So there's basically two types of terms when it comes to geometry where we have um, undefined terms and defined terms. So anything that is an undefined term is a word without a formal definition. So any of the undefined terms is going to be the topics of actually our first section, a point, a line, or a plane. So if you look here, a point has no dimension. It is a location in space and is represented as a dot. All right, coordinates can be assigned by points. All right, usually they're by letters rather than numbers. So like point A right here, and then you could also name it as point A in another way of identifying with it. If we look at a line, it says a line has a length but not a width or a height. Therefore, a line has one dimension. It represented by a line with two arrowheads to indicate that it extends without end. So it goes from each end into infinity. And there are a couple ways you can identify lines. You can call it by a singular letter or a singular symbol, like right here, you could call it line L, which is not part of a point on a line. Or you can identify a line by the points that are on the line. So like I have points A and points B on this line. So I can say this is line AB or even line BA. And these should have arrowheads on the ends to identify that they are lines and not just line segments. Plane is a two-dimensional flat surface made up of an infinite number of points and a infinite number of lines. The plane extends to infinity in both directions. When you illustrate a plane usually is represented as a parallelogram like we have right here. Although any 3 points uh, not on the same line, there is exactly one plane. You can use 3 points that do not lie on the same line to name a plane. So here, if you look at this M, there's no dot there, so there's no point. So that's just the way to illustrate that particular plane. So we say that is plane M. And then we have 3 dots, A, B, and C. They're not on a line. We can say that we could call it plane ABC. Defined terms are words that can be described using known words. So a segment, which is part of a line segment. In this case, we have line segment AB. Um, Also can be written like this as a symbol. Line segment AB consists of an endpoint A and an endpoint B, and all the points on line AB are between A and B. So you got an endpoint A, endpoint B. Anything between that is the line segment. Okay, another note is you can flip the letters and it has the same meaning. Another kind of line is a ray. Now this one here, you have to be really careful in how you label rays because one of the points is the end point and the other point is where the direction it's going to go to infinity. So in this case here, we have ray AB. And the reason why the A was written first is because that's where the end point is, and the arrowhead is going towards B. All right, on the other side of this blue one here, it's labeled BA, ray BA, because the endpoint is now on B, and in this ray is going towards A to infinity. Some other defined terms that we are going to look at is collinear and coplanar points. Collinear points are all of the points that lie on the same line. So the word linear is in there. If you go back to your algebra, if we look at a linear equation was y equals mx plus b, you drew a line. So think about that when you're looking at, the difference between trying to find a line and a plane. That's something we can reference. If you notice, we got A, H, and S. Points A, H, and S are all collinear. And we can also say that point Z is not. Same thing goes here. Uh, Coplanar points are all points that lie in the same plane. So I look here, I notice that these 3 points are in plane M. So I can say points R, S, and T are coplanar. And just like the other one, point Z is not. An intersection says the intersection of 2 or more geometric figures is set of points that the figures share in common. So in this case, we have line L and line M. They intersect at a singular point, point A. If you have 2 planes that intersect each other, they create a line. In this case here, it creates the line CD. So CD is the intersection of planes A and B in that particular example. Got opposite rays. Opposite rays, it says if B lies on line AC and is between AC, then they say that ray BA and ray BC are opposite sides. So if you look here on the bottom, we have a line segment with a point in the middle. A, B, and C are collinear. So we can say that because it's the opposite, so that's where we have, this is where ray BC and ray BA come into play, and that's what we can say that those are opposite rays in that particular line. So from here, they want us to give 2 other names for line LN. So I'm just going to switch the color here. So line LN is right here. So if I look here, it appears that this lowercase letter b is supposed to represent that line. So I can call that line B. That's one name to it. L, M, and N are all collinear, so M is part of that line, so you could also call this line LM. Another name you could also call it is line MN. Okay? Here it says give another name for plane Z. All right, so you have to make sure that that 3 of the points, that all 3 points can't lie on the same line. So you can't use L, M, and N. You have to use this point P in some of it, but you can choose the other, doesn't matter which other 2. So I can call this plane, call it LNP, or you could call it LMP if you like. It doesn't make a difference. It still would represent the same plane. Name 3 points that are collinear. So the collinear points we talked about are L, M, and N. So I'll say points L, M, and N are, in fact, collinear. 4 points that are coplanar, we could say that points L, M, N, and point P, those are all coplanar points in this particular example. Now looking at this, it says give 2 other names for MQ. Well, you could flip it and call this QM. So that's another way of naming it. Also, we have this lowercase a that represents that red line. And we could say that it is line A. Another hint, anytime you're dealing with dashed lines right here, that is supposed to represent geometry hidden lines. So that means that this particular line intersects this plane, and anything that's under is behind it is represented as dashed lines. So, and then finally it says name a point that is not coplanar with points L, N, and P. So the only one that's not coplanar means any points that are not on the plane, would be this one right here, and that is point Q. Here it says give another name for Vx. So I got Vx is right here. So W is part of that. So I could say that it could be VW. So line VW. It says name all the rays with point W. So looks like I got a ray here, 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 and here. So I could say that WV is a ray. I could say that WY is a ray. We could say WX. And finally WZ. Give another name for YW. So YW is right here. And it can extend over here. So I could say that this is YZ. Could also call it WZ as well. It's another name. Here they're asking if V, X, and X, V are the same ray. Explain. The answer is no. The reason is because they have different endpoints. The first one's endpoints at V, the second point endpoints at X. So we go from there. The next question here, it says VW and VX, are they the same ray? In this case, yes, because they have the same endpoint. And also they're going in the same direction. So if you look here, VW goes here and it's still going to go on infinity, and it also crosses through X. So yes, they are in fact the same ray. Here they want you to sketch a plane that intersects a line that intersects the plane at more than 1 point. Okay. So well, here's my plane. And I need a line that intersects the plane at more than 1 point. Really, it can't happen because you only have the line intersects at this 1 point here, and I got dashed lines representing that's the bottom. And it can only intersect at 1 point. Here it says sketch a plane and a line that is in the plane, sketch another line that intersects the line and the plane at a point. So you can go here and sketch a plane, and it says, and a line that is on the plane. So I'm just going to make my line right here. That's on the plane. And then sketch another line that intersects the line and the plane at the same point. So now I got that line. It's going to intersect right there at both the line and the plane. And we got my dashed lines to show the hidden lines from here. And that is being able to identify points, lines, and planes. Hope this helps. Till next time.